Good morning. My name is Aaliyah Milburn. We're going over balanced brackets. My team members are
Tyus Dedner,
Joanna Harris,
and Marcus Spratley.
Here's a slide where we're going to be talking about our team contributions. Tyus Detner went over the software development, designing, implementing, and managing software programs. Joanna Harris was over troubleshooting problems, monitoring, fixing any areas in the code, and evaluating system performance. I was over software architect, determining the software requirements, guiding and assisting the development team throughout the process. Marcus was over the project overview. He was in charge of researching, identifying areas for modification, and making sure the paper and PowerPoint is updated.
So our project involves making sure that we had balanced brackets in a string. And a bracket is considered to be like a parentheses or a curly bracket or an open bracket or just a normal open bracket, square one. So brackets are considered to be a match pair if the opening bracket and occurs to the left of the closing bracket of the exact same type. And as you can see, the three types of match paired brackets. And so the matching bracket pairs is not balanced if the set that it's enclosed in isn't matched. So for example, as you can see, the curly bracket, the open bracket, and then the parentheses actually interrupts the second open bracket. That makes it not balanced. So by this logic, the sequence, we will say that the set strings that we're sending to our program is balanced if these conditions are met, that it has no unmatched brackets, and that the subsets of brackets enclosed within the confines of a matched pair of brackets is also a matched pair of brackets. And when it defines whether it's balanced or unbalanced, it just says whether it just returns yes, otherwise it'll return no.
So our algorithm utilizes a stack, and if the index character is a starting bracket, then it's pushed to the stack. If the index character is a closing bracket, then it's popped from the stack. The closing bracket is compared to the top of the stack to see if they match. After the completed transversal, if there are starting brackets left in the stack, the function returns false, meaning the set is not balanced. Here, our algorithm shows the code with the function is balanced that utilizes the stack operation. And these are a couple of test cases from our algorithm.
Okay, currently we have our compiler pulling up, so we use this Repel It compiler online to run our algorithm to show that it works. You'll see that we have our code set up to where the input will have it set to where that the number of brackets that is input will then be outputted saying yes or no, signifying whether or not that bracket is balanced. So we have three different examples we're going to run through right now just to show how it works. So with the first one, it's copied and pasted in there. You see it'll say yes or no. The yes signifies that that one is balanced, and the no signifies that bracket is not balanced. So we're going to run through a second one. Give it a second, it's going to load in. All right, so we have yes, no, yes. So same thing here. First one's balanced, second one's not, third one is. And then our last one, let's run through a third example. And then we have a yes, no, yes. So you see that the first one is balanced, second one's not, and the third one is.
And this concludes our presentation. Thank you.